let's start off. So we're going to talk about today infrastructure as code with Bicep and ARM. And if you were in my talk yesterday, we talked about Terraform. So this is sort of a segue to the Terraform talk, sort of trying to bring the same type of ease of development for infrastructure as code as they have with Terraform. So my name is Brian Minisi. I'm a solution architect at Neudesic. I'm also a Microsoft MVP. I'm the organizer, one of the organizers of the TechBash conference and one of the organizers of Philly Azure. So just talking about the TechBash conference, it's in the Kalahari resort in Poconos Manor. And this year it's going to be on the dates of October 19th to the 22nd. So it's a great conference. And if you're interested in going, you can go to techbash.com and take a look at it. And when we open it up, you can sign up for it. All right. So infrastructure as code. So what are we talking about when we're talking about infrastructure as code? The whole idea of IAC is to deploy repeatedly and reliably using a script that you write, just like any other code or a developer would do. So out of the box, Azure provides these capabilities with Azure and Azure Stack using Azure Resource Manager or ARM templates. So it's really easy to create automation. The only problem is that writing ARM templates is difficult, but there is support for third-party tools such as Terraform, Ansible, Chef that can do the same thing. So as I said, with IAC, we want to be able to approach things and have the same process that developers have for the operations team. This way, we're all working the same way. We're all following the same steps in the process in order to deploy. So what we do is we write our script, we plan what will happen, how it's going to get deployed, and then we deploy it. And we change our script again and to go through the same process, just like a developer would do. And that's an iterative process that goes on and on. So that parallel between application development and operations space is exactly what IAC is trying to address. So Project Bicep, what is this? So it's brand new. It's something that just came around a few months ago, actually. It's a domain-specific language. And what it gives you the ability to do is to create your ARM templates in a declarative way. So if you look at ARM templates or if you're experienced with ARM templates, you can see how daunting it is to create them. It's a very high learning curve. And it's definitely something that people don't like to do. But Bicep wants to create that abstraction layer on top of the ARM, over ARM and ARM templates to make it much easier to write ARM templates. And it also gives you the ability to compile your Bicep files. And what that does is it not only compiles like regular code compiles, so if you have a syntax error, it's going to fail the build. But it also, when it does compile, it compiles down to a standard ARM template. So it actually creates an ARM template for you, which gives you the ability to deploy, just like you would deploy any other ARM template, either locally using PowerShell or AZCLI or through pipelines. So the goals of Project Bicep are to provide this abstraction layer, something that you want to have very approachable, something that can be learned very easily. And also, you want to have that ability to modularize it so that you can reuse your code. And this way, you're not doing copy and pasting. You're able to reuse. But the main thing is to build the best possible language for describing your ARM templates and deploying your infrastructure to Azure. So this works with Azure. So one of the things that you have with ARM templates is, it's a JSON script, and you don't really know if it's going to work until you actually try to deploy it. But with Bicep, like I said, you can compile it down and build it before you even go to that level of trying to deploy it to see if it will work or not. So Bicep is very new, as I said. It's still an experimental language. It's in the alpha version, so it's not something that we want to use for production at the moment. But it will be.
Hey, Brian.
Yes.
Hey, Brian. Hey, you're just FYI, you're like kind of, I mean, we can hear you, I guess, but on my side, you're like kind of tuning in and out. Like you're 1 second you're really loud and 1 second you're really low. So I just wanted to, I'm not too sure if everybody else experienced that. It's just me,
Okay.
but just want to let you know.
Yeah, I'll just try to stay still. All right, so right now it's not covered by Azure support plans, but in version 0.3 it will be. So currently it's in version 0.2, and I believe version 0.3 is going to be coming out pretty soon, probably in the spring. So other limitations of it, there's no support for the copy property that you would use in ARM templates. There's also, you don't have the ability to do single line object and arrays. It has to be multi-line at this point. So that's not supported. And there's also no native support for PowerShell or AZCLI. And this is really one of the big things at the moment. It's because you can't compile it using PowerShell and AZCLI, which means that if you're going to be using these in pipelines, for example, like Azure Pipelines, there's no built-in way to compile these. However, in GitHub, there are built-in actions that you can use in order to compile it. And we'll take a look at both of those. All right, so the first thing I want to show you is where you can go and get Bicep. So in GitHub, there's a Bicep repository. And this is where things are developed. And you can see here it's in 0.2 version, and it's in alpha at the moment. But you can go here and you can look at all of the limitations and how to install it and some of the syntax for creating it. So installing it, there are a number of ways you can do it depending on the platform or the OS that you're using. For Windows, you can just come here and do latest Windows installer. Now, if you're going to do this now, you're going to get this type of error down here saying that it was blocked because it could harm your device. So all you have to do is say keep, and then come here and then say keep anyway, and then you'll have it right there to deploy. It is safe to deploy. It just hasn't been signed, I guess, or recognized. So you'll also have, if you're going to be working in VS Code, you have an built-in extension that you can install from the marketplace. And this makes it very, very easy to work with Bicep files within Visual Studio Code. And that's exactly what we're going to be doing today. We're going to be doing our work in VS Code. All right, so let's get started with that. All right, so here I'm connected to a repo in Azure repos. And I have an ARM template here that we want to actually write out as a Bicep file. So we're going to take this JSON and write our code. You can see how many lines this is, how complicated it looks. And this is a very, very easy ARM template. It's as simple as you can get. It's just a app service and an app service plan. When you get into heavy duty infrastructure, these ARM templates can really explode and get super complicated. So here we have a Bicep folder and we have our main.bicep file. So what we're going to do is build this out by writing within our main.bicep. So all you have to do is create a file with a .bicep extension, and after you install the extension within Visual Studio Code, you'll have IntelliSense and color coding and all those great things that you would have with any other language. So we have parameters here, as you can see. So the first thing we want to do is build out our parameters. So we have a few that we have here, and let's get started with that. So I'm going to come over here. And the first thing we want to do is just create our params, as I said. So by doing that, you just do param, the name, the param, and the type. So we have other params too. Come here, take a look at what this is. We have hosting plan. And this is also a string. All right, so we have a SKU parameter too. And we're just going to keep the default value for this. So we're not going to do anything with this. We're not going to necessarily create a param that we're going to override, but we still have to account for this. And let's see, what type is this? This is a string type. Okay. So that takes care of our params. Now, for all different types of params, we have object params. So if we wanted to do something like this, we want to have tags, we can go object equals, and then do an object type of thing. As I said, this is something that has to be multi-line. Moment. And let's just create anything. All right, so these are our params. So if we tried to compile this right now, we wouldn't have any other definitions other than parameters. So down here, we can easily compile this once you get your environment set up by typing bicep, build, and then the name of the bicep file. Right, so what it does is it creates a JSON file, which is your ARM template. And you can see here, it built out our parameters. So that's really nice to do. And if you had a syntax problem here, something like this, and you tried to build it, it should fail. This is where you get that real-time compilation feedback. All right, so the next thing we want to do here is create our resources. So down here we have the app service plan and we have the app service. So when we go to create this, the syntax that we want to use is resource. We want to name this. And what this will do is give us the ability to reference this later on in our script if we need to get some property from it. So we also need to have the type. And you can see we have IntelliSense here for the type. We do .web. We have server farms, and we can choose whatever version that we want of server farms. So we'll just take this equal sign, and our definition is going to be happening underneath here. And it even gives feedback of the things that we're missing. So we're missing a bunch of things like location and name. All right, so we're going to say the name, and we're just going to have it be this variable. And the location. So as with ARM templates, we could use functions, ARM template functions within Bicep. So we don't have to do anything other than resource group deploying to the same resource group. And we get the IntelliSense for whatever we want to find from that resource group. So we want to get the location. So it's going to take when we're deploying this, it's going to take the context of the resource group that we're deploying to, and it's going to know what the location is, and we can just use this in order to create that, to populate that during runtime. And with the SKU, we can have the SKU parameter up here. So let's go over here and just populate what it is. So it's S1. But you don't have to put the values here. Ideally, what you would do is override these values during a deployment. And we can also have our tags. With our tags parameter. So this is our definition for our app service plan right here. And you can see it's not nearly as wordy as what we have here within an ARM template. So it's much easier to code this way. All right, so the next thing we want to do is create our app service itself. So it's the same type of approach. We want to have resource, the name of it in case we need to reference it later on, and the type. In this case, it's sites. We build out our definition of this resource right within the curly brackets. So we're going to use that parameter for the name of the app service. Location is going to be the same type of approach that we've used above. And we have some properties. So we've got to tell it where what the app service plan is. So our IntelliSense makes this much easier to do. So here we have to give it the service plan ID, and that's how we're going to reference it up here. So we'll do service plan dot, and then we have all of these different properties that we can pull, or these values that we can pull that are available for the hosting plan. So here we just want to have the ID. And that should be it. So if we go and compile it, let me just all right, so here we have the main.json, and it built out our definition in an ARM template way. So we could just take this ARM template and we can deploy it just like we would deploy any ARM template. So a couple things that I want to show you here is, in our regular ARM template, we have to tell it what to depend on. So we have to tell it that we need the app service plan created before we create the app service. And that's why we have this depends on pointing to the resource ID of this type right here. So in our Bicep file, all we had to do was tell it what the service ARM ID is, and it automatically generated that depends on for us. So we didn't have to go and write that. So what makes this great is that it abstracts a lot of these details that we would have to do normally through copy and pasting. So if we committed this, we could either then run it in pipelines, or if we wanted to run it locally, we can actually use PowerShell or AZCLI to just deploy our ARM template just like we would deploy any ARM template. So even though we create this main.bicep file, really we want to deploy the JSON file or the ARM template that got created from it. Now there's also a capability to decompile ARM templates. So you can actually take an ARM template, and I won't do it here, but you could do bicep decompile and the path to the JSON file. And what that will do is it will take your JSON file and turn this into a bicep file. So there are a lot of ways that you can do this. However, it is pretty simple. You don't have a whole lot of commands that you need to learn or understand. You just have to understand the syntax of your bicep file and how to write it. So one of the things I want to really talk about here is how do we deploy this? How would we do this in automation? Because that's the whole idea of infrastructure as code, is we want to have it be part of automated pipelines, so we know that the infrastructure is going to get created the same way every time. So let's go take a look at two places where we could do this. One is Azure Pipelines, and the other is GitHub. All right, so let's go to our Azure Pipelines. So I have a team project. And within this team project, I have the repo that we just were working with in VS Code. We have our bicep file here. I didn't commit it, so this is the one that's in there already. And all we have to do is write a pipeline that is going to deploy or build this bicep file, and that will create in the release. So that would be the build part, is compiling the bicep file into an ARM template, and then the release stage will actually deploy the ARM template only. So there's nothing new to learn there. We would just override the values if we're deploying to dev, test, prod, or whatever environments we're deploying to. Now the challenge, however, is there is no built-in way in Azure Pipelines yet to build a bicep file. So the way that this works is when we're running a build within Azure Pipelines, we could either use a cloud-hosted build machine, or we can use an on-premises build machine. So with an on-premises build machine, of course, we can install the exe, set it to the path, and within the environment variables, and we can easily set that up. But if we're going to be using cloud-hosted build machines, it doesn't really have the bicep exe in it. So we have to have a way of installing the bicep exe on the cloud-hosted agent. And also we have to have a way to build that, none of which is supported right now by Azure Pipelines. So we got to find a way of doing it. So there's a person named Nick Randolph that wrote something that we can use. So he wrote it in GitHub, so I had to take his repo and bring it into Azure repos. And this is basically what it is. It's a bunch of files and scripts and things, very complex. It's something that you definitely don't want to have to write yourself. So this is just one of them, but it calls, this thing calls many different files within here. So I brought that over so that we can use it within Azure Pipelines until the support happens. All right, so let's go over to Azure Pipelines and take a look at how our pipeline will look. So I have a pipeline here called Bicep Demo. And within here, we have our definition of our YAML. So these are the instructions that we're going to use in order to build and deploy our Bicep file. You can see here we have a trigger that's none. We're going to do it manually. And we have a resource section here. And what this is doing for us is this is going to our local repo pipeline templates that we already saw. And this is going to have the code that Nick Randolph wrote. So what this repository resource is going to do is bring this repo into our build or into our working directory so that we can use it going forward within our build steps. So then we have our variables, and some of the variables that we have are specific to what this repo and these build templates are going to need. So we have to have our path to our Bicep file, which is at the top of the repos. There's a Bicep folder and then our main.bicep file. And then we need to tell it what the name of our ARM template's going to be. So that's for the build section. And then we have our deployment variables here. And one thing we need here is our environment that we're going to deploy to. And we'll take a look at that. We call Bicep Dev. So we go to our environments here. I create an environment called Bicep Dev. And then we have our variable group that's going to be used during our release stage in order to deploy our infrastructure. So if we go to our library, see we have a variable group called Bicep Dev. And this has all the information that we need in order to deploy our ARM template. So we have our hosting plan name that we're going to use, the location, which we only need this for our ARM template step, which we'll see in a minute. The resource group name that we're going to be deploying to, our service connection, to our Azure subscription ID, and also our web app name. So the idea here is for every single environment that we will have a different variable group. And of course, we can store our values in Key Vault and link our variable group to Key Vault if we need to. But here I just put all the values within the variable group itself. Okay, so here's our variable group. So now we have our build stage. And these are the steps for our build stage. So we have to tell it what pool image it's going to be. In this case, we're going to use our Windows latest pool image because we're using the cloud hosted agent. And then here is where we're using the template that Nick Randolph created. So this is going to do the actual build of our Bicep file and create our JSON file that we can use for deploying. So we point to the template using the pipeline templates resource that we defined up here. And we're telling it a path that we want to go to. So this is our bicep.yaml file that was written within that other repo. So some things we need to pass in is a name, the path to our Bicep file. So right now we have this Bicep file path, which we defined up here. So it knows where to find our Bicep file. And then here, this is a variable or a parameter that's going to get populated with the ARM template, the path to our ARM template. So once this thing runs, it's going to populate this variable. And then the next steps in here are just copying our artifact and making it available for our release stage. So we're going to copy it to the build artifacts staging directory. And you can see here the contents are this bicep.arm file path. So here, bicep, and then .arm file path. And this is going to give us the path to our Bicep file. So the next thing that we're going to do is publish our artifact. into our artifact staging directory, and we're going to have it be in an artifact name folder name drop. Any questions about that before we continue? All right. So the next thing that we need to do is deploy. And this is just going to be a normal ARM template deployment. So we're just going to follow the built-in steps that we have and the tasks that we have within Azure Pipelines. So here we say it depends on the build because we have to have the build first. So this won't run until the build runs. We have to define what our variable group is. So this is a variable that we have up here. So this is where it's going to get the values in order to run our ARM template. And then the rest of the stuff here is just our plumbing for our deployment. So we have to specify the pool image, which is Windows latest, and the environment. So this is that environment dev that I showed you earlier. It's set up as a variable here. So Bicep dev is the name of our environment. So we're going to use a run once strategy for this. And we're going to download our build artifacts from our drop folder so that we can do a deployment, or we can have our JSON ARM template available to us. So the final step here is actually using an Azure Resource Manager deployment task. And we just have to fill in our variable values for here. Our service connection, which is coming from the variable group, our subscription ID, the resource group name, the location. That's why we need a variable in the variable group for our location, which is East US. And then we have to have the path to our JSON file. So it's in the drop folder. And then we have the name of the ARM template, which was set up at the top, right here. But the most important part of this, of course, is our overriding of the values. And this is going to give us the ability to deploy to different environments. We're going to use the same ARM template to deploy to multiple environments, but we're just going to pass in different values for its parameters. So here we're going to pass in the site name and the hosting plan, because those are two things that were not defaulted within our ARM template. So when we go to run this, it's going to compile the Bicep file, like I said, create the ARM template, and then we're going to deploy it to our resource group in Azure. So let's go and do that now. So we're going to deploy it to our resource groups, and it's going to have a name Philly in it. So just to show you that it hasn't been created yet. And now we're going to run it. So we're telling it which branch to run on. And the stages that we're going to deploy to are build and dev. So here, if we just wanted to do a build, we could do that just to see, but we're going to do both in this case. So let's run. So it's going to take a couple minutes to run. It won't be too long. So if anybody has any questions, this would be a good time to discuss.
So yeah, can you hear me?
Yes.
Yeah, so it sounds like, well, you did mention at the beginning it's alpha. When can we expect to start using this? And how would you say from experience, how much easier is it than ARM?
It's hugely easier than ARM. I mean, it's good to have a background in ARM, so you just understand how ARM templates work. But as far as the learning curve for writing it, it's super simple. It took me an hour to basically learn it.
Okay, that's good.
It took me years to learn ARM templates, to become proficient in ARM templates. So if you come from a development background and you understand infrastructure and ARM templates, it's a very easy transition to Bicep.
Okay, since I don't know ARM, you said I should learn that, but like, can I just skip that? Because I'm here kind of just getting a feel for it. Can I just skip ARM altogether, and maybe like, let's say in 6 months, would I be able to just jump into Bicep and see my way through without knowing ARM?
Yeah, absolutely.
Okay.
You just have to understand the syntax and the different parts of an ARM template that you would need. Like I said, we have the resource step. You have to know the parameters to pass in, such as the name of the resource, the location, any other properties. So just as long as you understand that part, it's very easy to learn. So you can always go and look at ARM templates to just understand what the different properties are, and write the Bicep file. Because right now, the documentation for Bicep is very limited, but there aren't that many commands that you need to run. You saw the one that we have was the build and decompile. Those are the ones that you would use 99% of the time. So it's very simple as far as the syntax, as far as building and the commands. But you still do have to understand how Azure resources work, what type of properties and parameters you need to pass into creating a resource. So if you have an understanding of Azure resources, then it's pretty easy. Otherwise, you have to learn it.
Okay, then at least I know like resources. I don't have to learn ARM, right? I just have to know Azure resources, then I can jump into Bicep.
Right, exactly. So that's the whole idea, is to abstract that complexity away from you. So you don't have to know ARM.
Okay, thank you.
As far as it being ready for production, I'm not sure. I heard that version 0.3 is going to be the production version. And that's, a couple months ago, someone from the product team told me that it should be coming out this spring. So we'll see.
Okay. Thank you very much.
Yeah. All right, so we completed the build and the deployment. So let's go look at the artifacts that were created from the build. So this main.json file was created. And if we go look at it, we can see it's exactly what we expected it to be, as far as in an ARM template format, which allowed us to pass in these parameters in that release task in order to deploy our ARM template. So it deployed to the dev environment. So if we come over here and we refresh, we should see our new resource group here. And we have our app service plan and our web app. So everything looks great. And you saw what it took to do that. Very little code. So of course, this could get much more complicated depending on the resources that you're creating. But you're using the same syntax for every single resource. Whereas in an ARM template, it could get pretty kludgy, especially if you have to pass values around and you have to know how to do the resource IDs in order to get the values that you need for subsequent resources that might depend on a previous resource that was created. Whereas here, it's just IntelliSense. It's kind of like Terraform in a way. So that's pretty much what Bicep is supposed to do, is be as approachable as Terraform is in the development of these infrastructure as code templates. Okay, so we have this, and we ran this in pipelines. and we had to go through somebody else's code and bring it into our repo, into a repo within our Azure repo in order to do it. And that's unfortunate, but I'm sure that compiling and installing Bicep on a hosted agent is going to be added to Azure Pipelines. Hopefully, by the time the production version is available, so we don't have to do what we just did with our repos here, as far as bringing in the other person's repo and using that. However, let's take a look at GitHub. So I guess, as I said, GitHub has Bicep built into it, so you're able to create actions that use Bicep. So here is my repo in GitHub, and you can see it's the same repo that we had in Azure repos. And we have our Bicep file here. So we want to create an action for this. So actions in GitHub can be anything that you need to do, any type of workflow. It's really a workflow system. So you can have different types of actions to do things other than deploying code. You can do any type of workflow that's built in. So actions are really more than just building and deploying code. It allows you to specify things based on events that could happen, such as scheduled events, webhook events, or manual events. So to create an action, actions are created within a folder called .github workflows. So if we come here, we can see that I created a workflow called Bicep build, and it's a YAML file, but it's a different syntax than we saw with Azure Pipelines. So here we have the name of our workflow. We have our event. In this case, we could have push, pull, delete, any type of webhook event, pull requests. There are a lot of different webhook events, but saying workflow dispatch makes it a manual event. So this will only get launched if we manually kick it off, which is perfect for the needs of what I'm doing here. But in the real world, we would want to have this part of a pull request. We would want to have it part of a merge, for example, in order to kick off this workflow, just like we would do with Azure Pipelines. In Azure Pipelines, it's called triggers. But in GitHub, it's much more powerful than just triggers. All kinds of different things can be used to kick off a workflow in GitHub. So here we have jobs, just like we had in. Yep. Question? Can you see this? Do I need to look at larger? Okay. So we have a job here, and it's going to be called build and test, though we're not doing any testing. The name, which we're going to call build. This is the type of agent that we're going to use. So it's going to create a cloud-hosted agent. In this case, we're going to use a Linux machine to show you that this can also, Bicep can also be compiled on Linux machines, not just Windows machines. So the steps we're going to go through is first, we're going to check out our repo, just like we did in Azure Pipelines. And here we're going to do our build, and this is the built-in step or action that we can use for this in GitHub. So I didn't have to go and pull down somebody else's repo and add it to my repo in order to build this. It's built right in. So all we have to do is tell it, where our Bicep file is. So in this case, we only have one Bicep file, so we're just going to say find any Bicep file within our repo. But you want to get more specific if you have multiple Bicep files within your repo. And then the other thing we're going to do here is upload our ARM template into our drop folder. So this is going to be our artifact. So we have an upload task that we can use, and we're going to tell it where to store our Bicep file. And then if we're going to do a release at some point, there's also a download, not just an upload. There's a download artifact step that we can use for downloading it. All right, so let's go and launch this. So in GitHub, we have an Actions section here. And this is where we have our actions. So all of our workflows would be listed here. And since we told it to be a manual trigger using workflow dispatch, we have this run workflow button here. So we can tell it what branch to run off of, and we're going to run the workflow. All right, so this is kicking off right now. And you can see it's queued. And we have a nice log like we did in Azure Pipelines. And like I said, this is running on a Linux machine, so you'll see this type of stuff in there. Okay, now we're checking out the repo. And see how quickly this had? We ran the Bicep build using our alien cube action. And these are all the commands that were run for that. And then we're going to upload it. And it said it found one file to upload. So it completed successfully, as you can see here. So if we go to our summary, we see we have artifacts here. We have an artifact. So we can click on this. And open it. And we have our JSON file here. So this is our compiled ARM template that we got through GitHub too. So you can do this in Azure Pipelines, though it's more difficult right now in Azure Pipelines, or in GitHub, where it's very easy to do. So if we were going to deploy this in GitHub, we would just use that download task and then use ARM deployment action within GitHub in order to deploy our ARM template to the environment that we need to deploy to. All right, so that's everything I have to show. Wanted to leave a few minutes for any questions or discussions that people might have. Has anybody heard of Bicep before today?
No.
Yeah, it's absolutely brand new. So it definitely makes life a lot easier and approachable for ARM templates, because I hear all the time from people saying they hate ARM templates, they're way too difficult to do, I don't understand them. This is to address that. Of course, you could use Terraform or third-party tools, but this is the Azure built-in way of using a domain-specific language for ARM templates. So any other questions? Has anybody done infrastructure as code in their life, in their work life?
Yes.
And what has been your experience with that?
Well, for me, I've worked with teams that have migrated from on-prem to the cloud. So getting used to infrastructure as code is a little bit of it took a while, but it kind of really forces you to it helps you manage your resources and helps you easily migrate from one environment to the other. So you kind of get to see the benefit of it right away.
Right, exactly. I mean, especially when you get into very complex infrastructures.
Yeah, and you have your like, especially when you go into auto scaling too, you really run into that pretty quick.
Yep, exactly. So imagine this being a very, very complex infrastructure. It would still be much easier. This might get very complex in itself, but nothing like it would be if you did it in an ARM template. All right, so we only have a couple minutes left. Any other questions?
Not a question, but a comment. I heard there was a question earlier about skipping ARM ARM templates and just going directly to Bicep. I'll go back to my experience with Terraform. It's like I would have to go to the console to figure out what to add to the Terraform script. It kind of feels the same way with this one. Like you got to go back to the ARM template to figure out exactly what attributes are available to you, what properties are available to you. So I don't see any way of skipping it.
No, but it can be easy, because actually sometimes what I do, especially with like private endpoints or VNets or things like that, I create them manually in my sandbox.
Yeah.
And before I actually export it or actually create it, you have ability to export your template. So you can export your template and see what the ARM template definition is going to look like.
Yep.
Ahead of time. And this makes it much easier to see what types of properties and parameters that are needed in order to create your Bicep file. But after you create your resource and then go do an export like I'm doing here, there's a lot of stuff in here that you'll see that you won't need.
The extra
template or in a Bicep. It's like very specific to the resource that you created. So you can't just actually take this. You can see what it did here. Like a lot of this stuff you don't need. Like we didn't do anything with hostname SSL states. We didn't do anything with reserved, all these type of things. This stuff just gets created automatically. So if you went here and looked at it, you would think, oh my God, I have to do all this. Nah, you don't. There's a lot of stuff that just gets created automatically for you when Azure creates the resource.
You get good at ignoring
all that stuff, right? Unless you need to change one of these things, I don't want to be involved in it.
But I do like the simplicity, though, of Bicep. Just, I guess, a lower barrier of entry.
It is. It definitely is. And like I said, except for those limitations, it's pretty powerful right now. I would not, because a lot like the copy property, single line arrays and objects, those things are nice, but they're not blockers. But those things are going to be corrected, I would assume, by the time 0.3. Those features will be available when version 0.3 comes out, I would hope. It's kind of what they said.
We'll get there.
Yeah, definitely. All right, so we're a little bit over our time. So I'd like to thank everybody for coming, and hopefully this will make things easier for you when you have to do infrastructure as code.